So with this, we will go to our next presentation, which is on construction of 3 large-scale robots capable of constructing a UHPC shell, repair of culvert, and automated MFL. I believe Dr. Aziz Namini is going to present also this project.
All right. Okay. All right. Thanks, Armin. Dr. Anthony ABRAHAO is a PI of this project, and I was asked to give this presentation. This is a very exciting. Let me give you some share with you a thought that is really it's related to this project, but also related to civil engineering. I think this robotics and automation is an opportunity also beyond helping or providing a good solution for our infrastructure, but it also, I think, it has a capability to portray civil engineering in as a very technical area and attract basically the kids from the high school, middle school in the area. So, and I think the automation is here with us. Automation is something that's gonna, over the next decade, I think you're gonna see to be very popular in the construction. Construction industry has been very much behind in development of the automating the construction processes, inspection processes, and so on. And with all the infrastructure challenges that we have, really, this is a very timely idea. So we have an applied research center here at Florida International University that they have a very good capability in the robotics area, and we work with them, especially with Anthony ABRAHAO and his staff and students. The people who are involved with these projects are a group of electrical engineer, mechanical engineer, structural engineer, work together actually in a common space to develop. And under these projects, the objective is to develop a 3 full-scale functional robots. Anthony has been able to keep the cost very low, extremely low, but at the same time, because we build everything ourselves. Okay, so we don't buy any robots from anywhere. Everything is 3D printed, and fabricated with the students. So there are 3 items I'm going to show you. These are very exciting. One of them is to automate the inspection of the something like a segmental concrete bridges using a magnetic flux leakage method. Another one is printing basically a formwork using a UHPC, and the last one is automating the culvert repair. And I will show you a few things. Okay, now when you come to the robotics, really there are the 3 different ways you can look at teleoperation, where basically with the joystick, basically you have a robot that moves, and then the operator is controlling that. It's a supervised autonomy, which is really the autonomous operation under the human supervision, and requires a sensor and augmented perception. For example, that's one of them. The virtual reality, that's how you control. And then the last one is a fully automated, where the human really is not involved. So our goal is basically to reach this level 3 that you see over here. The challenges, of course, that we have in the case of the structures is that we are not in areas where it's a clean environment. Okay, so you have to deal with the gust. For example, you inspecting a segmental concrete bridge. I mean, these are very high up, and there's lots of wind gusts in there. The environment is not, it could be dusty, and so all these things needs to be taken into account. The first one is to automate basically the inspection of the segmental concrete bridge using basically magnetic flux linkage method. I'll give you some example. Under a different project that was funded by Florida DOT, we have developed a complete technology to inspect the condition of the steel element that is embedded inside the concrete, like segmental concrete bridge. We tested the bridge actually in Sarasota, Florida, that had a post-tension rod, and we are able to match our data with the borescope data, so we are able to manually, when we inspect this thing with the magnetic flux linkage method, to tell where the corrosion activities are. And these are some of the equipments that we have. Very clearly, I mean, we can see where the corrosion is, and we are getting excellent results. Now, the problem is that, for example, when we, this is a one bridge, I won't name it, but when we were inspecting a segmental concrete bridge, it's not easy. I mean, it's cumbersome. You have to close the traffics. You have to do lots of stuff, and it takes really time consuming. So what we are doing right now, we are looking at a couple of ways. One is using a drone that has the sensors that can transfer the sensors to the surface of the segmental concrete bridge, and then basically inspect it. I'll show you this video, for example. This is just this video is a drone, smaller scale. The drone that we are going to be using is a much larger than this one, more sophisticated. So what you see over here, it's not very apparent, but there is a wheels that is attached basically to the frame. It's a payload on top of the drones, and the drone basically transfers the sensors and these wheels to the surface. It could be the side surface or bottom surface, okay, and then it scans it through. Basically, using these wheels, basically the drone is pushing the wheels against the surface, and then it moves along the surface. Another idea that we have now, sometimes we have very wind gusts. We have another robots that does, you can see it here. So these robots basically can walk through it's using basically a suction and moves in any kind of surface, and it's very useful if you have a very high wind gust. And now everything that you see is a homemade. There is nothing here that is purchased. So that was an MFL. Another one is what we call is a printing. We have developed a concept called the section printing. So it's not a layer by layer printing, but it's a section printing. And I'll show you some applications. So our idea is that this is, again, it was developed under a different project. You print basically, rather, the formwork is made of the UHPC. You bring it to the site, you stack them on top of each other, and then you try to basically, you put the steel reinforcement, you fill it with the concrete. So the idea, for example, here is that you bring basically you put the reinforcement, you put the shell, the UHPC shell. Now I'm going to show you this UHPC shell. Now we have a robot that's going to be printing that, and then you fill it with the concrete, and then there you go. We have actually made these things manually. Let's say, for example, this is a UHPC shell that was filled with the concrete. And here is a section printer where, rather than doing a layer by layer printing, what we are doing is we're printing a section at a time. And here we are using a UHPC, and here is basically printing a UHPC shell for a column. So now this is, I think within the next few months, we are going to be able to print a full scale, something close to, I think, about 10 feet height. And here is another shot of it. So rather than building these shells manually, we are going to be printing. And if we can get this one to the point that, imagine now you can go and just print these things, it's a really wonderful job. Okay. Another one. This is the last one. We are in the process of, hopefully within the next 4 or 5 months, building a robot that goes inside the culverts, and we can do a shotcreting. Okay. I'll show you some of the technology that we are using is a 3D camera trying to scan the area, trying to see what the condition of the culvert is. We had a bunch of columns in the field that the student that you see with the 3D camera was able to capture this figure, so we can see exactly what the condition is, identify the cracking, and so on. And this is the robots. This is the robots that we are building. Basically, the robot moves. It has an arm, and it has basically the nozzle here, and the nozzle, and then there is basically a supply of the UHPC. And we've done lots of work to develop a UHPC mix that is suitable for the shotcrete. And then with these robots, basically what it does, it goes inside, it can adjust basically the height, be within a few, maybe 1 feet or so of the surface, and then shotcrete basically the culvert. Now, this project, I think this one, we will be ready. We've done lots of work in the area under the separate projects, development of the UHPC mix for the shotcrete. That's a separate project. We are using that as an input to this project. But this robot that you see down here will be ready in the next few months. We are looking for, if you are a state DOT and listening to this, we are very much interested in using this robot and actually in the field to retrofit the culvert by spraying the UHPC or shotcreting. And this one should be ready hopefully by toward the end of the summer, let's say 2022 or the fall of that. So anyway, so these are some of the exciting ideas that we are working in the robotics area, and these are going to be all of them that you see will be field implementable hopefully fairly soon, less than a year. So I hope I stayed my time again, Armin.
Yes, you are a little early as well, Dr. Azizi. Let me see if the question we can use your valuable time to maybe answer. The question say you mentioned UHPC as a material, but do you envision that other material can be used with the same or similar robots?
Yeah, that's a good question, Armin. Let me show you something here that's really kind of tells you why we are. There is a reason for all this madness. The idea that we have, for example, for the shell, our idea is that there are contractors that say, "Oh, ABC is a new technology, so therefore it's there's a premium for that." Now what we are saying is that, okay, now rather than building a formwork out of the plywood, let's build a formwork out of the UHPC shell. And by the way, this idea is also proprietary idea, and we are saying, okay, let's build it out of the UHPC shell, and then the size is going to get smaller. If you use a UHPC, it's very durable. It doesn't let anything to penetrate. So now you can place a lightweight concrete inside. Now the total weight is going to go down. And so there's lots of advantages in using a UHPC. You're going to be dealing with a smaller size shell to transport it to the site. It's going to be almost maintenance free because nothing penetrates through that. You can use a lightweight concrete. The total weight of the structure is going to go down. So those are some of the reasons right now we are concentrating on only using a UHPC, and I truly believe that the UHPC used strategically, I think it's the future of the bridge engineering, with the fact that there is a non-proprietary UHPC that can produce, I mean, less than $1,000 per cubic yard. I think the days that we say that you only have to use a proprietary UHPC is over. I think within the next couple of years, I mean, you're going to see non-proprietary UHPC is going to be used, and that's a great news. Several universities working in that area, and I think as a result of that, UHPC is going to become a much more common material to be used. So our concentration is that maybe somebody will look at some other material.
Oh, thank you very much, Dr. Aziz. Other question is, has there been any interest from precast concrete producers in the UHPC shell concept?
You know, that's an interesting part. Early on, there was some interest on the precast industry. But if you are interested, if you are listening to this, if you are interested, we would love to work with you, because now we are taking this whole idea, like I said, to the point that we are basically printing these things, and this is going to be within a fairly soon. The high quality product, UHPC shell. I mean, you cannot ask for that. So if you're listening, if interested, please send me an email, aazizina@fiu.edu. We love to work with you guys.
Thank you, and I like this interaction, because this is exactly what the purpose of this research day is. Another question, Dr. Aziz Namini, asking what research, if any, has been done on the bond between UHPC shell and internal concrete?
Okay, that's a good question. The bonding between the UHPC shell and the we've done work in that. I haven't shown you, but it's a different problem than casting a UHPC against the normal strength concrete. You're going to have to rely on some sort of mechanical action in order to provide that composite action, because the surface of the UHPC is very smooth. So it's not like, for example, a normal strength concrete that can sandblast and then get the aggregate exposed. There is no aggregate here. So you have to rely, and we have done some tests and we've got the solution for that, but you have to rely on mechanical actions.
And Dr. Aziz, I mean, from your answer, it's something, comments come to my mind, is that like the picture that you're showing, printing shell, this is going to be filled with normal concrete. That confinement, wouldn't it somehow take care of the bond?
I don't believe you can. If you have, if you print this, right, and if you just put a very small bending, okay, you will get tremendous amount of composite action because of the friction, right? And even under the axial load, due to the Poisson effect, I mean, you think that you're going to get the composite action, but I believe you still need to have some kind of mechanical action to make sure that composite action is there. You may not need much, okay, but in my opinion, I mean, you have to. It will be a bit risky just to rely on the friction or the Poisson effect to get that composite action.
Okay, thank you, Dr. Aziz Namini.
Thank you, Armin.